it's demo time. It's time to have some fun. Get into the nitty gritty of a programming problem and how to go about tackling that programming problem. I like to show the process. So we're going to begin with a few things, and then we'll start our demo. Hey Sandra, I'm with my students again. We're talking about Java and we're doing another demo. I had a question about Java. What is its niche? What problems does it solve? Or where is it used the most?
Absolutely. Let's dive right in. Java is really well known for being a go to language in enterprise environments. It's practical and it runs on a huge variety of platforms, which means you can write it once and run it just about anywhere. It's heavily used in big business applications, Android app development, and a lot of server side systems. So it's kind of a powerhouse for anything that needs to be stable, scalable, and cross platform.
Oh, that's the key, cross platform, isn't it?
You got it. That's really one of Java's big claims to fame. The whole write once, run anywhere philosophy is what made it super popular. It's like a reliable tool that you can pull out for all sorts of projects, especially when you want your code to run on different systems without a headache. So, yeah, cross platform is definitely the star of the show there.
And what do they call that middle language again? That makes it cross platform.
Ah, you're talking about the Java virtual machine and the bytecode.
Yeah,
Basically,
why? Yeah, it's why they have to install that the JDK kit, right?
exactly. You got it. That's why they need the JDK, the Java Development Kit. It's got all the tools to compile your code down into that bytecode and run it on the JVM. So once you got that in
Wait a
place, you're.
minute. JDK kit. What? I was talking about that middle language. What was that again? Talk to me about what that's called.
Oh, I got you. Yep, that middle language is basically the Java bytecode. So when you write Java, it doesn't go straight to machine code. Instead, it turns into bytecode that the JVM understands. And that's the secret sauce that lets it run anywhere. So yeah, it's that bytecode layer in between that makes all the cross-platform stuff happen.
So I know NetBeans was written with Java. So what is that we're installing that's needed? That bytecode interpreter. What is that called when we install it?
Yeah, exactly. So that thing you're installing is the Java virtual machine, the JVM itself. Basically, it's the part that takes the bytecode and runs it on whatever system you have. So when you install something like the JDK or the JRE, you're making sure you've got that JVM in place. And that's the piece that interprets the bytecode and makes the magic happen under the hood.
Okay, where would I install that so that I can run NetBeans? Where would I get that? And what is the file called?
Yeah, absolutely. So to run NetBeans, you'll want to grab the JDK, which you can usually get straight from the official Oracle JDK download page
Okay,
or
now
from.
that JDK, that's what actually contains the Java virtual machine.
Yep, you got it. The
Ah, so wait a minute.
JDK.
So that JDK goes to another that Java virtual machine runs on another different type of operating system, but it runs on that and interprets from your code to the current system that it's on. Okay, I think I got it.
Absolutely, you've nailed it. That's exactly how it works. The JVM just sits on top of whatever operating system you have and it makes sure your Java code can run there. So you've definitely got it all connected now.
Okay, that's great. So we were going over the stack, of course, and the call stack and variables. How do variables go on the call stack?
Yeah, absolutely. That's a fun one. So basically, when you're dealing with the call stack, each time you call a method, it creates a new frame on that stack. And any local variables you declare inside that method, they kind of live in that stack frame. So when the method is done, that frame pops off and those variables go away.
And that
So
starts
that's
with the opening brace, the function call itself, the opening brace and the closing brace, every variable inside goes on the stack, and then once the function gets done running, it goes off the stack. Okay. Hey, I've got. I would like to generate a problem, but students often have a rough time actually getting to where to start, and I like to give them an IPO chart to work on. So can you describe what an IPO chart is?
Absolutely. So, an IPO chart is a really handy little tool that stands for input, process, output. It's basically a way to break down a problem into those three parts so that students know exactly where to start. You list out what inputs the program needs, what steps or processes it has to go through, and then what the final output should be. So, it kind of gives them a nice little roadmap before they jump into coding.
Excellent. All right. So we were talking about conversions, mixed expressions with different data types, and conversions and casting, and we're on the normal chapter 2 introduction to programming. Can you come up with a good programming problem scenario that we can solve with, or I can solve with them? And remember, don't give me the solution. Oh, but do put in an IPO chart for it so we can have an example. List the scenario and then give an example of what the IPO chart would look like. And then I would like to solve that problem with my students. Can you do that when we go off live?
Absolutely. Let's set up a nice scenario. So imagine a simple problem where the students need to convert temperatures. Maybe they're writing a little program that takes the temperature in Fahrenheit and converts it to Celsius. So the IPO chart for that will look like this. The input is the temperature.
Hold on. I'm going to go off live and I'm going to ask you for the scenario. Now that one is a simplistic one. Can we go for something? Actually, that one's actually pretty common. Can we go something a little bit more involved, but not too involved than the Fahrenheit? Because that's just too close to 101. Let's dive a little deeper, but not too deep. So I'm going to ask you for a couple scenarios when I get off live. Thank you, Sandra. Appreciate it. Right. You know what? We are going to do the Fahrenheit to the Celsius, but we're going to do both ways. So a little bit more involved. And this also we'll see how the language does, but this is where things can get in real trouble, because you notice how the formula is been given in most places you look. They're just using 32. There's no point 0 there. And they're just using 5 divided by 9 as whole numbers. So this is usually where students kind of what they sort of have the problem with those conversions and working with that. So let's break it down. What we need is we want to convert from Celsius to Fahrenheit and Fahrenheit to Celsius. 101. But come on, both ways. Let's do it. Let's have some fun doing it. What we want is some input. So we're going to need the Java scanner and Java input number. Okay. So all the input that we need from the console comes from this utility, and we bring it in as an import, and it's part of our tool chain. And we can use that to get information from the user. And this is a little bit ahead of where we're at, but we can get some examples of getting some numerical values for input to do our Fahrenheit to Celsius conversion. So what we'll get here is the input from the user with the scanner. And let's go and look at an example of that. Oh, there's our stuff here. And actually, yeah. Let's start on the input. And I think for this, let's foolproof it and start it out at a higher data type than is needed. It's a simple program. We can foolproof it with doubles because there is some division math in there, and we got to round it up to 2 decimal points. That's our output in our input process output chart. Where are we at with that? Let's see. We'll come back to it here in a little bit. So the input process output chart, our input is going to be let's see, here we go. This guy. So any value, Celsius and yet we'll hard code the difference. We're not going to do any decision modes. We'll just do it both ways and hard code it. So let's do it first with input. What we'll do is we'll ask the user enter F, and we're going to do the Fahrenheit to Celsius first. Oh, actually, you know what? We can do it all together. We can ask the user for F and then do it, and then ask the user for C and then do it. That'll work. Okay, now you notice how I am putting all my variable declarations at the top. This is good top-down design. We want all variable declarations at the very top, and in this case, these guys are just junk. So when I add the Fahrenheit, which I'm going to call F, FAR, FAR, I'm going to initialize it with 0.0. And then I'm going to do the same thing for Celsius. And you notice here that I've got it at the very top. So this is, you can do it this way. You can define it. Now this is what we call definition code. This is declaring it, putting it on the stack. And it's totally different from doing this far is equal to 0.0. This is runtime code. So I can't set the breakpoint on this line anymore. I have to set it here. But Java, we can do a little, and most languages now allow us to put that together. So we can do it that way, which is kind of cool. It's nice and easy. Okay, there we go. 0.0 doubles. This is it should be a literal double. Let's do a cleaning. Okay, cleaning went good. Let's get our input. So this is where we're going to use the scanner. And, for references, what we can do is just look up, well, hey, what do I want to do? I want to input a Java double. Input Java double. Throw it into Google, and you're going to get an AI response, and you're going to be able to get just kind of a general idea of how it works, and then you'll see, oh, scanner. Well, what scanner? Scanner's up here. Well, what do? They instantiate a scanner. So Java and C#, a lot of these higher level languages, they use object-oriented and create memory right off the stack, or not the stack, but the heap, using that new operator. So this memory right here, this declaration and assignment is happening on the stack. This is creating a pointer on the stack that points to the first byte of a scanner that inputs your keys and all the functions it contains from the heap. All right, and remember, the heap is just all the rest of the memory. You say, hey, operating system, I want a scanner. It's 200 bytes. Give me the first byte of a block of 200 bytes, and I'll store it in my reference called scanner, and then we can use that as from then on, as it's instantiated. So now we can use input, that input object, by using the name, its instantiated name from its imported library, to get next double. It's built for us to use as part of the tool chain. What was the example again? References are a beautiful thing. And what we got right here? Boom, and then what we got? Next int. No, next double. That's right, right there. And then what that does is it goes to the console input and grabs it from standard input, stdin and std out, standard output. Okay. So, hey, what was it? I'm already forgetting things already. Scanner dot next double. Well, let's just do this. Living a little dangerously, but there we go. Oh, nope, 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 don't do that. Don't you do that. Okay, and then let's just test this. And I always say, get your memory, print your memory. But with this function, what it does is it actually returns the value from the standard input console. And so what we'll do is we'll take FAR and assign it to that function call that goes to the console and looks for input, and then converts it from ASCII, because when you enter input in the console, it goes in as the ASCII text, and it has to convert it from ASCII to an actual 8-byte double in RAM. And that's what this function does, and that's part of the tool chain. So we should be able to now print that. So get your memory, print your memory, guys. Just get kind of in the habit for a little bit while you're learning, and it's helpful. But you know what the real helpful thing is to do is to set a breakpoint. So usually students get this far and they'll run this and just kind of test it out like we're going to do right now. Just general run it and see it run, and then you see the enter F, and then we'll put in 45, and then it'll output 45.0, which is the double. And you see the output down here. I don't think, oh yeah, here we go. Nice, I love NetBeans. Thank you, NetBeans. It's so beautiful. You are beautiful, NetBeans. Oh, thank you so much. Oh, jeez. Sometimes I forget about that stuff. My eyes were dying. Okay, I bet you yours were too. Jeez. All right, let's see. Next double, we got it. Now it goes into just copy paste. So usually I would just get this, and then I would grab this, copy it, paste it, and then just rename it. Because often once you get the base code, repetition is very common with computer science. And then just rename it here. And I'm pretty confident that works. And if I want to know if it works, this is how you debug with inputs. Sometimes it gets students confused kind of, for what's going on. So I'm going to set a breakpoint up here. And I'm going to hit the debug up here. I'm going to debug it so it stops at the breakpoint. I can see what's going on with my variables. And if I was calling functions, the call stack would show up. Now, I can step over these and see what's going on. I look down here, cell. I don't know if I cannot increase the size of that one, unfortunately. Now, we got this guy. Now, see right there? I just stepped over and you see it kind of blinked out. What it is it's over here in the console mode and it's waiting for input. So we got to put it in the input, hit enter, and then the runtime goes back. Say go back, and now I can step over. We entered, hey, it ran that code. Now we say enter C, and when I run this line, it's going to wait for that input. Boom. Now it's waiting for input. You see it's kind of lost. You're like, what's going on? What's going on? It's because it's waiting for input. And then your runtime comes back. That's all. Sometimes that's hard but it's a good thing to go through to understand the mechanics of what we're actually doing. So now we got the input. Now we're up to, what are we to now? We've got this. All right, input. Boom. Got our memory. Printed our memory. Let's go to process. All right. So now we got this formula, and I'm gonna just break it down from here. And this is normally what students would do. They would grab this. And I did this too. And when I say students, I mean like everybody on this problem for the first time. You notice that 32 in there? It should be 32.0, guys. And it may be apparent. We'll see if Java lets us do it. Some languages it would break it, but it's a good starter. Now, as you look at the input process output chart, what we got to do is process that particular value. You notice how I'm just kind of putting a placeholder in here. And look at these weird characters. That's going to play hell in the editor. We probably don't want that. And the comment might not even help. It might cause a lot of problems in the future. We'll see. You know what we should do is just get rid of those, because those are weird. F equals C. Actually, you know what? These formulas suck. Let's go find some good formulas. Fahrenheit F to C. All right, F to C formula. All right, that's a little bit more digestible, I think. Let's see. C equals F minus 32 divided by 1.8. Okay. So we're not going to get dangerous here with weird characters. In fact, we're going to get rid of that. F is equal to, oh, we're doing this in the wrong spot. Oh my gosh. Let's just grab that and throw it in here and see where we're going with it. Where the input output is. That one is there, so I was in the right spot. So where C is equal to, these look like some better characters. You know, here's a nice trick. If you do not know if you got weird characters in a copy paste, bring up Notepad and just paste it in Notepad, and then when you get it back, it's going to be nothing but raw ASCII usually. I don't know if things have changed, but it really helps to get it to where it needs to be. So we can actually use those characters in our code if we wanted to, but we're not going to. We're going to set, because our whole thing is get Fahrenheit, output Celsius. So we're actually calculating our Celsius value here. So that's our process. Celsius is equal to Fahrenheit, FAR, that's what we're using for Fahrenheit, FAR, minus 32. Now this is where we get in trouble, possibly. And then times 5 divided by 9. Okay, that's usually what would initially be put in. Now let's see if it actually runs. Let's see if Java will like this, because the problem here is we're taking far and subtracting it from 32, which is a literal int. That is a temporary int behind the scenes, and there's a conversion that needs to happen before that subtraction can happen. But first, this is going to happen. 5 divided by 9. That's going to be interesting. What happens there? Well, let's break it down. Let's put it in the debugger and find out. Okay, let's do this. Okay, debugger. Okay, no. Continue down. I'm going to hit continue here, and it'll just run all the way down to my next breakpoint. There. All right, there we go. I'm going to step over. Enter the Fahrenheit. Let's do something, I don't know. Let's go to the output window. Enter in the Fahrenheit. 65. Okay. Hit enter. Okay, there. Now it goes into the calculation. So here's kind of where we can, where we can actually get in to what's going on. We can go and select that and say add watch, new watch. Well, we know what 5 divided by 9 is, but what does it break down to? It's an int. You see where I added it in, the expression 5 divided by 9, and it comes out as 0. So this is actually running. So it's going to be 32 times 0, isn't it? Let's do this. Add a new watch. Okay, so the next operation that's going to happen. Oh no, I messed that up. Oh no, this has to be done first. Nope. Nope, it doesn't. Look at that. What happens first? Not 5 divided by 9. It's 32 times 5. Let's get this down here. Okay. So if we take 32 times 5, we throw that on the stack, or on the watch. We know that that's happening first, and that comes out as 160. Then it's 160 divided by 9. So this turns into 160. And since this is an integer dividing by another integer, that's going to come down to 0. And then it's going to be 60. Let's see if I'm wrong. I could be wrong. 64. My input was 64, wasn't it? 65. My input was 65. So let's just get everything back to the way it was. Oh, I went too far. Control Y is redo, Control Z undo, and I use those very often. Okay, that's what we had. I bet you if we step over, it'll just run what we had initially. Yeah, it did. So Celsius comes out as 48. Okay, all right. I was wrong in the order of operations. Is that right? Let's do this. 65 F2, and we can just use Google because it's got automated that thing. 65, and we can throw it right in. 65 F2C. 18.33. We're way off. Okay, now there's a lot of ways we can fix this by casting and all that kind of crap, but the easiest way and this is why we do this exercise. It's kind of a start into the real world of processing. Okay, so what do we got? Should we get an output now that's a little bit more? Let's see if we're going to be doing this wrong or right. Let's run it again. Let me debug it. Step over. Okay, go put my input in. Let's do 65. Okay, step over. What do we got? What is Celsius? Let's go over here to the variables. 47.2. Ooh, something's really wrong. Well, dang, what can I be doing wrong? I've got the precision. I mean, I've got the conversions taken care of. But what is the order of operations that I'm doing right now? Well, according to operator precedence and associativity, 32 times 5 happens first. Is that what the algorithm calls for? What does the algorithm call for? And then I look over here and I see, oh, we first subtract 32. Then we multiply that by 5. And finally divide that product by 9. Is that right? I don't think so. Oh, that one fell into an AI trap for some reason. First subtract 32, then divide the result by 1.8. So the 5 divided by 9 needs to happen first before. Okay, let's do that. This happens on its own. So let's just put those two together. But this happens first. And then overall, this happens. Okay. Let's see if you love me or not. Do you love me? Yeah, you love me. Okay. So I'm being very explicit in my order of operations. I know it's already got left to right I can't even say the word right now. Associativity. Thank you very much. So this guy happens first. Then it multiplies by 1.8 because the 1.8 happens first. Okay. Golly, I think I got it straight now. Oh my goodness, what a stinker. So the process of taking mathematical formulas and making them real, there's various realities because of the mechanical nature of applying the science. And this is part of it. And this is just a little dip into the water for that. Let's test this out because from what I think it should be good. Let's put a breakpoint there. Debug it. Okay, good. Step over. What? Oh, duh. I gotta put my input in. Don't forget about that, guys. 65. Okay, good. Boom. All right. Step over. Is it 18.3? Let's look at my variables. It's 18.3. All right. I'm going to leave you guys to the rest of that stuff. Guys, go ahead and have fun with it. Do the other one. I wanted to give you a start on the process. Remember, input, process, output. That's what you want. We're kind of skipping out on some of the output. So, right here, decimal to 1 to 2 decimal places. There's tools for you guys to do that in. I'll let you guys play with that. Great. I think I got everything I needed to you for how crazy things can get when it comes to conversions and actually implementation and where the little gotchas are, and then also how to walk through it, how to mechanically see it. That's the key. And I emphasize that see it, guys, because if you're seeing it, if you're branched out like me, you got debug points, walking through it, looking at it, looking at the variables, looking at the call stack, looking at the functions that you're calling, everything. It's so simple. It's just numbers. Cleverly organized. All right? All right, guys. Until next time. Thank you. Bye.